what is a example of negative feedback. Now, let's say you are out in the cold and you start shivering. Okay, let me pull that thing here. Okay. Now, in this mechanism, if you're out in the cold and you start shivering, what is the effector organ? Like we said, there are three components. You have the receptor, you have the control center, and then we have the effector organ. Receptors are always, if it is the body, the temperature changing, so you have those temperature receptors in the body. Brain is the control center always. Now, what is the effector organ when you're out in the cold?
Your muscles.
Yes. So you should be able to answer questions like this. What is the effector organ if you're shivering or if you're out in the cold? Yes, it is the muscles. Now, on the other hand, if you're out, you're overheated and then you start sweating to cool down the body temperature. Now, what is the effector organ in that case? What is producing the sweat?
Sweat glands.
Yes. So the sweat glands would be the effector organ. Okay, any other examples of negative feedback? Give lots and lots of examples.
Like insulin to lower your glucose levels.
Yes. So maintaining your normal blood sugar level is another example of negative feedback. Now, what is positive feedback?
Childbirth.
Okay, that's one example of positive feedback. Any other example? Related to childbirth?
Breastfeeding.
Breastfeeding. And then there's another one we talked about, blood clotting. So know the examples of each one. Okay, so we're done with. Okay. Now, scientific method. What are the different steps in the scientific method? The first thing is
observation.
Yes, you observe something and then you go back and you do all the research on whatever you think is the question that came to your mind based on that observation. So what do you create? Hypothesis. So just know these steps, and this was another question in one of the worksheets you did. So you have the hypothesis, and then what do you do next after that? After you've created the hypothesis, what do you do?
Yeah. Experiment.
You do the experiment. And then what is the end? Here, accept
results.
So whatever was your hypothesis, either you accept or you reject, or if the results were not consistent, then you have to modify and do it again. So just know what are the basic steps of the scientific method. And likewise, what are the differences between science, non-science, and pseudoscience? What is science?
It follows the scientific method.
Follows.
Yes, something which follows the scientific method, like what we just talked about. And it is always peer reviewed. So that's why it is got a lot of backing, because it's not that you just come up with something. It has gone through a lot of different steps before you start following it. So it's science. Now, what is non-science? Example.
Religious beliefs.
Yeah. There's no scientific method. It's just your belief, and that's what you follow. So that is non-science. And what is pseudoscience?
Non-science that acts like science.
Yeah. Any example you can remember of pseudoscience?
Astrology?
Yes. Telepathy? Yes, that's all pseudoscience. Okay, so that's all in this chapter. Any questions before I pull up my next PowerPoint? Okay, I'll pull up my second one. You might want to know the structure of an atom. I don't think I need to go through that. You know that the structure of the atom, what is a proton, what is a neutron and electron, and what is atomic number and atomic mass. So atomic number is based on the number of protons, and a mass, atomic mass is the mass of protons and the neutrons together. So you might want to know those definitions. What is isotope? What is different in the isotope?
The amount of neutrons.
Yes, it's the number of neutrons which is different, and neutrons are actually neutral, so the charge does not change, but because of the neutrons, it makes it unstable. So that's why you have carbon 12, 13, 14. That's one example here, and that's what these isotopes are used in medicine a lot. You know, all the radiotherapy and even the gamma knife and all, lots of it is used in medicine. So that is what is isotope. So know what is isotope. Okay, then the next thing would be the types of compounds, ionic and molecular. So what is the ionic compound? What connects the different ions? What kind of bond is present?
Ionic bonds.
Okay, so what happens in ionic bond? Are you sharing the electrons, or are you donating and accepting the electrons?
Sharing them.
Sharing would be covalent. Ionic is one is donating and the other one is receiving. That's why they become ions, like sodium chloride. By itself, sodium chloride is neutral, it's a salt, but when you dissolve it in water, it breaks down. What happens? Sodium has donated its electron to chloride, so sodium becomes positively charged, and chloride, which accepts the electron, becomes negatively charged. So the kind of bond between these two is the ionic bond, where one donates and the other one receives. Molecular compounds are where you have the electrons which are shared. So that is what is that is covalent bonds. Okay, what are cations? What charge do they have? Positive. Yes, positive. So sodium with a plus sign, it's a cation. Calcium with 2 plus is a cation. And what is an ion?
Negative.
Negative. Example. Which one gets a negative charge?
Chlorine.
Yeah. Yep, you're right. So that is an anion. And here you have all these listed here. Okay, so what are isomers? Like we talked about isotopes, what are isomers?